As we talk about absolute value, the first thing I want to make sure is that you have that formula written down at the top right of your notes. So you should be on page 1 of the notes. And in the top right section where it's blank, I want you to write that formula. Okay. Next thing we're going to be doing is thinking through, what does absolute value mean? Absolute value is really the distance, how far is a number from 0. So the distance between 0 and a number. But whenever you measure a distance, is it possible to have a negative number? No, because if there is any distance to measure, it's a positive length. So that means that it makes all numbers positive. I really think of this as that measuring thing. So my memory clue is a ruler. Notice a ruler doesn't have negative numbers because distances are always positive. A number line has negative numbers, but a ruler does not. I'm going to give some simple examples just because we're just talking about absolute value. But if I take the absolute value of a -7, well, the distance between 0 and -7 is just 7 spaces. So it becomes a +7. Likewise, if I take a +4, the distance between 0 and that 4 is 4 spaces. So it stays positive. What would it look like if I just graphed the rule f of x equals the absolute value of x? This is totally plain. Nothing added, nothing subtracted, nothing multiplied. What does the plain expression look like, or equation look like? This is also called the parent function. This is what it is when it's plain. So I'm going to try plugging in some numbers. I am recording. The distance between 0 and -2 is 2. 0 and -1 is 1. 0 and itself? 0. How about 0 to 1? And 0 to +2? As we graph this, at -2, I'd still have a +2. At -1, I'd have a +1. At 0, it would be itself. Are we seeing the pattern here? It's kind of like a slope of up 1 over 1. Reflected on both sides of that y-axis. So it's a V shape. Anything we do to this, add, subtract, multiply, divide, is simply going to take this shape and change it. So the first thing we're going to look at is what happens if I multiply by a number. What do you say we go 3? So let's take those same numbers as I did before. -2 turns into a +2, and I multiply it by 3, and I get 6. What was that? We're going to graph it on the graph right here.
Wait, what?
Oh, this is the bottom section. Yes, A. So -1 turns into a +1 times 3 becomes 3. Zero stays 0, and 0 times anything is 0. 3 times 1 is, hey, we've already started reflecting, so I bet you I can tell you what the last one is without even calculating it.
7, right?
And then I'm going to graph it. And in -2, I had a 6. -1, I had 3. At 0, it was 0. And back up again. If I compare those two graphs, this one and the parent function, this one is up 1 over 1. And this new function is really up 3 over 1. It's almost like it took it and it stretched it. And that's what A does. This section outside being multiplied, we're going to call A. And that A, will either stretch or shrink vertically. It doesn't slide it. I'm not adding, it's stretching it. What happens if it goes negative? You guys told me. It flips over that x-axis. What happens if my number is smaller than 1? Oh, same section. Same section. I just want to know what happens if A is smaller than 1. It's kind of between 0 and 1. I'm really dividing by a number, right? So what do you think is going to happen to my original graph? My original graph was this. It's going to widen it. It's going to compress it vertically, right? Changing colors. Yeah, it would be if it worked. Thank you. So if I'm cutting it by 4, right, I'm shrinking it by 4. So what was 4 is now going to become 4 divided by 4. 1. I know, we've got this, right? So if what I'm multiplying by is smaller than 1, I'm really going to be squishing it flat. Notice your vertex, this thing, didn't move at all. I'm stretching it or I'm squishing it, but my vertex does not move. Okay, now we're going to talk about the adding portion. What happens if I add on the outside of the absolute values? What did we say? What happens if I move that K value? It moved up and down on that y-axis, so I'm only going to do one thing at a time. I took that original line, and because it's a +4, how far do you think it's going to move it up?
3.
up 4. And this goes 1, 2, 3, 4. And so my new point, same slope, just moved up. I didn't think we need to worry about the table. If you really want to make a table, feel free to plug in values. What do you think is going to happen if I go? That is just rude. Nope, can't do it. Can't make me. Okay, what happens if I say f of x is equal to the absolute value of x minus 2? Where do you think it's going to move? Down 2. Good. 1, 2. That is not going to be easy to see.
Like really dark.
I'm trying. Oh, whatever. You can see it better than I can. And then last one. What happens if I add and subtract inside? And that's where we talked about that h value, right? F of x equals x minus h. Why do you think I'm doing a minus on the inside? The reality is this. When you move that h value, it moves side to side, but it moves in the opposite direction of the number you see. So if you see a positive 4 in here, it's really going to go towards the negative. So my first example, f of x equals x minus 2. This minus 2 is really going to tell me that my original is going to shift 1, 2 to the right because it's the opposite of the negative. And it goes here. If I had a positive number in there, which way do you think it would move?
The side.
To the left. Good.